Hello students, welcome to the first lecture on the D and F block transition element, and this is the first lecture. In this lecture we are going to discuss some very important points relating to this D and F block elements, and this is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. So heading of this today's lecture is Introduction to D and F block elements. This topic, that is D and F block, we have already studied in the class 11 during the periodic table chapter where we are studying this, that we have observed one very important thing, that there are totally 112 elements as on date, and all those elements has been arranged in order of increasing their atomic numbers, and it has taken near about 18 columns, that is, which is called the groups, and 7 horizontal rows, which is called the periods, to accommodate all those elements. And these elements in the periodic tables can be classified as different blocks. Already we have understand that there is a 4 block of elements, that is S, P, D and F. S, P block element, that we already understand that it is basically, if we go through the periodic tables, it is basically in between the group number, that is a S block in the group number 1 and group number 2. P block, that is from group number 13 to group number 18. And now in this lecture we are going to discuss another very important class of element, that is D and F block, which is basically in the middle of the periodic tables, that is from the group number 3 to group number 12, and it is been extended throughout, that is the, if we consider the periods, it is basically in the periods, that is the 4th period to the 7th periods. So first thing that we want to discuss, that is already we have understand or discussed, that is the location of this D block element. So first thing that we are going to discuss, that is location of the D block element. Location of D block element. D block element is basically located between the most electropositive S block. This S block, between S block, we can write it between S block, it is located between S block and P block element. P block element. And why this element is called the D block element? Because the last electron, we can write why it is called D block, because the last electron enter in the D subcell, but D subcell of not the outermost subcell. It is not in the outermost subcell, but N-1 cell. Not in the outermost cell, but it is the N-1 cell, or this is called penultimate cell. Penultimate image cell. So why it is called d block element? Because the electrons has entered into the d subcell of the n-1 cell, whereas n is outermost cell. N represent the outermost cell. Why it is so? Because we can recollect when the filling of the electrons in the third period element. What we observe, third period means that n equal to 3, that principal quantum number is equal to 3, the last outside cell, outer cell, that is a quantum number of the outside cell, that is n equal to 3, and in that cell there is a different subcells, that is basically 3 subcells we know, that is one is 3s, 3p and 3d. 3s and 3p will be filled by the electron progressively, but 3d electrons will not enter in the 3d subcell. Before that it will enter into the next higher cell, outermost cell, that is the n equal to 4, where the 4s subcell will be first filled because of the energy constant, because we know the electron has been filled in order of increasing their energies. So 3d subcell has higher energy than the 4s. So first the electron will put into the 4s subcell, then it will go back to the previous cell, that is the penultimate cell, that is n-1 cell, whereas n is the outermost cell, and it will be filled there, and it is going to create the different blocks, d blocks elements. That is, we will understand later on the classification of the d block, that is the total 4 series of the d block element will be there, that will be understand in depth now. So we understand this is a d block element, and how it is called a d block element, and another terminology that is used, that is a transition element. This d block element also, this d block element is also called transition element. Why it is called transition element? Why it is called transition element? Because the property of the transition element is in between the S block and the P block. That is, there is a transition, means change of the properties is observed in this group, this block of D block element. That is why it is also called a transition element. Now we will discuss what we mean by the transition element. That is the definition of transition element. Definition of transition element. Definition of transition element, that is, what is the definition? That transition elements are those elements, in which atom in the ground state or any oxidation state or in the ionic state having the incomplete D subcell. It is having incomplete D subcell. Incomplete D subcell, that is, the electron we know in the, that will be D subcell has the capability of accommodating maximum 10 electrons. So it will have the 1 to 9 electrons. When it will have 1 to 9 electrons, we will call it is a D block transition element. But here we can observe the last element of if we see the period, the last element of this D block, that is zinc, that is cadmium, or that is Hg. All those are not transition element, but they exist in the D block group. That is, in the D block series they exist, but we will not call this is a transition element. Why? Because its electronic configuration, you will see in case of zinc it is 3d10 4s2, whereas in cadmium you will see it is 4d 4d10 5s2. Ag you will see 5d10 6s2. These are all D block elements, but this is not transition element. One very important statement we should keep in mind, that all the transition elements are D block elements, but all the D block elements are not transition element. That is why this zinc, cadmium, Ag, what we will observe, the basic property that we will observe in case of transition element will not be available in those elements. The most important, that is the metallic property. All our transition element you will see they are very hard metal, but zinc you will find it is a very soft metal. Ag is at the room temperature, it is liquid. So what we will observe, this is a thing that we have to always consider, that zinc, cadmium, Ag, because of the fielded D subcell, it is not the transition element, but it is a D block element. It is not transition element. We have to understand. So we understand the definition of transition element and how the zinc, cadmium and Ag is not a transition element. Okay. Now we are going to discuss another very important thing, that is the electronic configuration. Electronic configuration of D block element. What is the electronic configuration? That is N-1 D 1 to 10 and N is 1 to 2, where N is the outermost cell. N represents the outermost cell and N-1 is before that cell, that is the before cell, that is last cell of the last subcell of the before cell, that is N-1. So here in the D orbital you will find there will be the electron will be 1 to 10, and whereas in the S orbital the electron will be 1 to 2. Now a fourth thing that we are going to discuss, that is the classification. The rows of elements having 10 elements is called the series, transition series. So here also we observe, when we analyze the D block elements, what we observe, there is a 4 series of elements, and it is also the first series transition element is also called D series. Second series is also called 4D series. Third series is also called the 5D series. Fourth series also called the 6D series. And we will now discuss in detail in that series which elements is there with the tables. Okay. 3D series. In this case, we will take the element then its atomic number. The first series we know that is the 4s orbital will be filled by the electron first, then we will go to the 3D. The first element is candium, and first element is candium, and its atomic number is this. First let us put all those elements: candium, then titanium, then vanadium, then chromium, then manganese, then ferrous, then copper, cobalt, nickel, and then copper and zinc. So you see there is a 10 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 elements, and its atomic number is serially it has been put that 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Here you can see 4s already filled, that is why it will go to fill the 3D orbitals, that is 2 and 1, 2, 2. Now the D block element, this is basically D block element, transition element. Here the electron will be filled progressively in the D subcell. 4s subcell already filled. 3. Then here, as per we go for this electronic configuration, as per this, so it will be basically it will be 2 and 4. But this is not the correct thing. Correct thing will be this. There is an exception in the electronic configuration. So we will make it a star. So chromium has the exception electronic configuration. It because of this fact that we know half filled or full filled set of orbitals is much more stable, and there is a very little energy gap, and this exception is basically occur due to the one factor, that is the energy gap between the 4s and 3D is very less, and here 1 and 5 is a half filled orbitals, and they will be much more stable than usual electronic configurations. Then now there is another electronic configuration. You can see it can have this 2, 9, but again it comes the full filled orbitals is set of orbitals much more stable. So what will going to happen? It will take one electron of the S block will come to the D block, and it will be 110. Again there is the exception, and this is 10. So we understand this is the first series of transition, 3D series, where the exception is chromium and copper, and this is going to create a lot of difference in their properties also. That we'll understand when we are going to discuss the properties, physical properties and chemical properties of this transition element. Now we are going to discuss the second series. second series transition element. Second series transition element, or it is 4D series. Here also in the same way we will write all those elements. This is the element, it is atomic number. In here the 5s will be filled first, then the 3D will, this will be 4D. 5s and 4D. Here first element is yttrium, then zirconium, then niobium, then molybdenum, then technetium, then your rhodium, then ruthenium, then rhodium, RuRH. Then we will get palladium. Palladium is a very important class of element that you will observe. It is used as a catalyst. We know palladized charcoal when we are talking about the reduction process of in the organic chemistry. This palladium is a very important element. Then Ag or silver, the very precious metal, Ag, and then the cadmium. What is the atomic number? We will make it, this is the element, and this is Z, we will write atomic number, then 5s and 4D. Z, that is starts from 39, atomic number, zirconium 40, 41, 42, 43, 44, 45, 46, 47, 48. So this is the second series or 4D series. Here electron, 2s electron is already, 5s electron is already filled. That is why d orbitals is being filled progressively 2, 2. Now here you see there is again an exception. You will find that in the chemistry lot of exception, and you have to remember all those exceptions only. Here also you can see exception. That is, here niobium will be 1. It should be, as far as go by this 2, 3. But it will not like this. It will be like 1, 4, 1, 5, 1, 6, 1, 7, 1, 8. And here is again a big exception you can see. What is that? It should be this. But this has totally changed in the palladium. In the s orbital, there is no electron. It will be in the d orbital. And that normally happens due to the energy. Energy is very energy difference between these orbitals, 5s and 4d is very less. Then silver and then cadmium. So we understand in the first series, that is scandium to zinc, the second series yttrium to cadmium, and you observe there is a lot of exception in this period. That is, this is basically you can also write this is the 5th period. This exists in the 5th period of the periodic table. It is in the 4th period. We have to write also the period also. So this is a 2 transition series that we discussed. Now we are going to discuss another 2 series. And it is in the sixth period. If we go by the period, this is the sixth period. Now element, then atomic number, that is the 6s will be filled first, then 5d will be filled. 6s already filled now. So in this case, first element is lanthanum, and after this lanthanum there is a start of the another very important component element, that is the 4f element. Here the first 6s orbital will be filled. After that the 5d will not be filled. It will fill it 4f, because 4f is vacant now. 4f is vacant now, so it will going to give us is another class of compound that we will discuss later on, that is the 4f transition series, that is also called inner transition series. Inner transition series, after the lanthanum it will come, that is the 4f series. 4f of element, total 14 elements you can show. You can see this is the extra long period, you can see. So this is the lanthanum. After this lanthanum there is next element, that is hafnium. Hf is hafnium. Then titanium, T. Then tungsten. After the tungsten there is rhodium, then osmium, then iridium. Iridium is a very important. Tungsten also a very important element. Iridium. Then we will have the most precious element that we wish to use, that is iridium, and then platinum. Platinum is also there. Platinum, it is also a very precious metal. Platinum. Then Au. Au means gold, and after that Ag, mercury. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 elements is there. Here is atomic number. Again we have done a mistake. The element will be put there, and again we have to. This is element, and its atomic number is lanthanum has the atomic number 57, and here when we put the other elements, that is 14 elements, you will add this 14 element, it will be 71. That is, they are 58 to 71 atomic number. Now hafnium will be 72, 73, 74, 75, 76, 77, 78, 79 and 8. So here the 6s, here 6s and 5d. 6s will have 2 electrons, 5d is 1 electron. Here we will see there is not much of exception except in the platinum and gold, that we will observe. 2, there is 3, 4, 5, 6, 7. Now in the platinum you can see this will be 1 and 9, platinum. So here exception you can see, that is a 2, that is a gold on the platinum in this series. They say only exception is there, or there is no such exception. Okay, now that is the third series, that is the first series, second series, and third series. That is the first series, that is 3D series, second series, that is 4D series, and third is the 5D. Now we are going to discuss the 6D transition element. In this case, we will have these elements like this. First, we will have these elements. First, that is the actinoids, the first element, and after actinoids there is the F transition element, that is the 5F transition element, because before putting the electron to the 6D subcell, the electron will be first filled up in the 4F subcell, 5F subcell, and that is again going to generate another set of, that is called the actinoids, another set of, that is the A block element. So first element is the actinoid, that is, then second is Rutherfordium, then it is Dubnium, then Seaborgnium, then the element name is Boronium. All these elements, Boronium or Rutherfordium, that is after the name of the eminent scientist. After this Boronium, there is Hessium, then Meitnerium, then DS, then Rongium, and Copernicium. So total you can see the 10 elements is here, and this atomic number is actinoids have been 89. So we will add to this 89 another 14 atomic number. So Rutherfordium will be 104, Dubnium 105, Seaborgnium 106, Boronium 107, there is 108, 109, 10, 11 and 12, 112. And here 7s will already be filled, then it will have 60. 60 is 1, 2. There is no such exception you can see except in the Rongium. Sorry, this is 4, 5, 6, 7, 8, 1, 10, 2, 10. So the exception only in case of Rongium, you can see all other electronic configurations is the same. There is no such exceptions. So that is all the electronic configuration of the 4 transition series, and we have discussed, and we have also discussed the exception. Exception we observed in the 3D series, that is in the chromium and in the copper. In the 4D series we observed, we start from the niobium to silver, we will observe these exceptions, and in the fourth series we observe this. For the Rongium you will find these exceptions. So how these exceptions is occurred, what is the reason behind it, that we already discussed. It is basically the lesser energy difference between these orbitals. That is why that is there. And another thing, half filled orbitals and fully filled orbitals are much more stable. That is why it is. So that is all for today's lecture. In this lecture we have discussed about the very fundamental things in the D and L block elements, and in the next, from the next lecture onwards, we will discuss different physical and chemical properties of those elements, and we will basically concentrate on the 3 series, that is the first series, second series and third series. We will not concentrate on the 4th series, but compounds we will only discuss that is from the first series, that is the 3D block editors. That is all for today's lecture. We will again meet you in the next lecture. Thank you very much for watching.